Okay, so welcome to this presentation. Everyone participating will not be in the recording that I have just started. It will only be Hrefna, unless you will ask a question live, then you can also be in the recording. Otherwise, you are safe and outside the recording. The recording will be put online, unfortunately not today, but on Monday morning. So you can see the recording after that. It's Hrefna Vignisdottir who is presenting today, and the presentation is Life Cycle Assessment of Winter Maintenance Operations. So I give the word to you, Hrefna, and ask the rest of you to mute your microphones.
Yes, thank you. So good morning and welcome. I'm going to talk about my project in life cycle assessment of winter road maintenance. First, if we go through what I'm going to talk about, I go a bit about my background and the background for the project, and then into why I wanted to do this one. And then I talk about the methods and information that we are working on at the moment, and shortly about challenges, and then we can have some questions. Yeah, so my background, I graduated from the university in Reykjavik in 2008. Then I worked in the industry for a couple of years before taking my master's degree at industrial ecology here at NTNU. I worked again for a few years and came back to NTNU. It's a great place to be. And I'm now working on my doctorate degree. I would really want to mention our teamwork. We are 4 people, Baba, Gaylord, Rain at the University in Agder, and me. We meet up quite regularly, and we have contact both through mail and Facebook and Skype. So we talk quite a lot. We have found that we have more skills and more abilities together than individually, and we want to take advantage of that. We have been developing concepts together after the main author of a paper has come up with an idea or information that we think we can use. And I also want to mention this because it has worked really well for us. It gives us great discussions. It brings us more insight into the topics, and it's also just more fun because now we're not alone anymore, we're more together. And then shortly about the why. For Statens vegvesen, it's obvious that the winter maintenance is to ensure mobility, traffic safety, and they also want to limit environmental effects from construction and maintenance altogether. It's to provide good service and to take care of the road capital that exists. I mean, it's a huge investment, and good maintenance is really helpful. One of the most important methods to ensure mobility and traffic safety is friction control. You can achieve that by either salting or gritting. So where salting is mostly used in highly trafficked roads, and with while gritting is more in communal roads and which has less traffic. The winter maintenance operators, they follow a guideline. So the activities include visual monitoring the situation visually, as well as monitoring through weather forecast, and then applying the right winter maintenance. So that can be de-icing or anti-icing, as well as snow and ice removal with a plow. For me personally, winter maintenance, I knew before I started that winter maintenance was mostly omitted from LCA off-roads. It has not been investigated to any degree, and it's mostly rough estimations of fuel consumption that have been made. I wanted to know more about the effects of winter maintenance, and I also wanted to be included in future LCAs of roads. So I would like my information to be used as much as possible. I'm curious about the procedures and planning of winter maintenance, and it is also important to me personally. But I will come back to that later. So sustainability in transport is only achieved if all aspects of transport sector is optimized. So planning and designing new infrastructure, as well as maintaining the existing ones, is really important. To be able to account for all aspects of the infrastructure lifecycle, LCA is often used. LCA accounts for emissions from the whole lifecycle of a product or a service, from production and to the end of life. LCA is mostly beneficial to avoid problem shifting. That's probably the most important part of LCA. The studies that are available on road infrastructure are things like fuel use of the vehicles, road construction materials, pavement options, and lighting, for example. I show here the picture of BIM because the building sector has in the past years been going steadily and actually really well towards sustainability. And they have a lot of information regarding materials, procedures, design. And now there is a work to include environmental LCA information within the BIM system. So our dream in our team is that a similar system would be developed for road construction, so that LCA would automatically be imported. So when you design a road or come up with a new idea, you would instantly get a report of the emissions of the project. But yeah, that's the dream. And my contribution would be to the red dot over there, or the red circle, so the maintenance of the road. If we look first at anti and de-icing operations, I have investigated the past trends in amounts and distances driven by winter maintenance vehicles for distributing salt. So the information has mostly been from Mängderapporten. And when I started, the first job is to find a functional unit. Finding a functional unit for LCA of roads is generally very difficult. The road is really unique if you compare to, for example, doing an LCA of a food item or a chocolate bar. You can take all the materials, the production procedures, the transport, the storing, and then somebody buys it and eats it. While in the road, every road is really unique. Every meter is almost unique. So that makes it very difficult to know what functional unit to use. If you use a kilometer of road, that's not gonna apply to the next kilometer of road. So the option is to take all roads and make an average, and making an average, that was sort of what I thought was best for the anti-icing operations. So I've taken average kilometer during the winters from 2010 to 2014. That was the information at that time. Of course, there are huge differences between the different parts of Norway. The climate is just really different. So you have both inland, you have coastal regions, and you have almost up to Arctic climate. So from very mild and very wet to very stable cold. There's also the difference in population and expectations about the winter maintenance. In the Oslo area, you have a lot of salting, and that's both due to population density and the amount of traffic on the roads, but also due to the weather there. So there you have kind of milder weather, a bit more wet, and not as stable. So the temperature is often fluctuating up and below zero, which makes salting really important. Also, because of the high traffic, you have categorized the roads as clear or barveg, while in the north, maybe because of the less traffic, you might have more winter roads where snow is allowed in some amount on the roads, or even whole compacted roads. Going through the criteria that I used, as I said, it was official data from Statens vegvesen about the distances and amounts of salt for those winter seasons. Salt today comes mostly from Tunisia, but also from Spain and rock salt from Germany. Tunisia, then you have excavating and production of the salt, and then transport to shore, and then it goes with a freighter from Tunisia to Norway. That also applies to Spain and Germany. It all comes with a freighter. I have also information about where they stop in Norway. So there's a few harbors that they stop at. So we have the distances from the production country of the salt and where they end up in Norway. And from there you have transport on vehicles to a centralized storing facilities. And then from there they go to our local storage facilities. There lies a bit of a limitation because there are many storage areas for salt, like local storages, so that I have only used average estimations of the distance that is driven with the salt. I also assume that the cars that are distributing the salt, the actual winter maintenance vehicles, are driving with 50% load. That's a normal procedure within LCA. A bit of results. It was the impact categories that I chose are shown in the table, and in the paper we clearly saw that distribution of salt is the main contributor of emissions. They have almost all the emissions. The only impact category that is slightly different from the rest is the acidification, and that is the freight of salt with the sea transport. But it's such a small change that it still is distribution of salt within Norway that is the main contributor. So if you look at the distribution of salt, it is mostly from, well, if you look at climate change, the global warming potential, it is mostly from burning the diesel while driving. And then if you have material depletion, then it is the car, the vehicle, that is the main source. So the car and the driving is the most is responsible for the most emissions. Life cycle analysis has been used to estimate the environmental impacts of the chemicals of the salt and the distribution. yeah, so as I said, the distribution within Norway is the highest, has the highest impact. Because of winter maintenance is highly linked to driving distances, and the material use is, it is important to reduce the loss of salt on the road. So when they're distributing the salt, it is important to try to optimize the speed and the speed of the spreader, how they spread the salt. Because if you have more effect of the salt, you would have to drive a little bit less. So training and awareness of the winter maintenance staff, that could contribute to less loss of both salt and therefore driving distances. However, the use of salt and the driving distance and in general is very weather dependent. So it should be kept in mind that winter maintenance operators, they also report that using anti-icing and especially anti-icing is very beneficial. It makes snow removal easier, and that in itself reduces fuel consumption. So here's a bit about the amounts or the distances driven for winter maintenance during 2015 to 17. As you can see, it's a whole lot of distance, and you have here comparison to the circumference of Earth and the Sun. So it's a huge distance. It's really a lot. So it is important to reduce emissions as much as possible. So I'm gonna talk a little bit about the route that we have mostly been analyzing. So it's the E39 west of Orkanger down to Vinjeøra, if that's correct. I don't know if you can see my pointer, but yeah, it's down there at the sea level. So we've looked at that stretch, and we have looked at elevation during that stretch and the flat sections, but we have excluded in this first analysis we did, we excluded tunnels, because obviously it's done a bit in the at the entrance, but not within the middle of the tunnels. We have information there about, based on GPS points from actual vehicles that have been driving the last winter. So we have GPS coordinates that are linked with fuel consumption, speed, distance, total distance, and stuff like that. During this section from Orkanger, the elevation isn't really much, but this is the elevation profile. This is the distance on the x-axis. You can see the distance from Orkanger. So you can see it's not high elevation in a short of time. But we wanted to look at the elevation because to see if how that affected fuel consumption of the winter maintenance vehicles. If the flat sections would come out similar, or how it would come through towards the fuel consumption. We have also looked at differences between the months. So we have the average fuel consumption for the whole winter, and then we have taken averages for each month to see the differences. There wasn't a lot of activity during September and May, but October and especially November, December, January and February were high in activity. So the highest fuel consumption was recorded January and February of last year. So obviously the fuel consumption of winter maintenance vehicle is affected by many factors. It is affected by the vehicle weight, the design, the speed, the road conditions, but there is an indication that when snow is heavier, and there are more frequent weather events like January, February, that the fuel consumption goes really up. The weather station near Orkanger reported that last winter, during November to January, there was the most precipitation, which also reflects in the fuel consumption that we saw. We had the highest fuel consumption in January of last year. At the same time, the temperature is often below zero, so that also suggests that there is more snow, obviously, and that it does reflect heavily on the winter maintenance vehicle fuel consumption. When we looked at the road gradient, the fuel consumption was also affected, but when we looked at fuel consumption and the road gradient, it seems that the road gradient didn't affect as much during the winter months as it did in October, April, because it seems that the weather has more impact on the fuel consumption than the road gradient, at least in this part of Norway, or this particular stretch. But this stretch we kind of categorize as a coastal road, even though it's not exactly by the coast, but yeah. So to be able to perform whole LCA of the winter maintenance, there are several things that we need to know. So we need to know what materials are used and what equipment is used. And to be able to analyze the equipment, we need to know the type of vehicle and the extra weight of any tools that are used on the vehicle. So the plow and the spreader and the extra equipment, we need to know how much they weigh and what materials they are. And then we of course need the salt and the fuel. The vehicles are mostly general trucks, but they are very different. It's not the same type of trucks every time. So that makes it a bit, you have to take kind of an average vehicle. And the vehicle also has a lifetime and maintenance plan, so that needs to be accounted for as well. Regarding the salt, we will include the salting LCA that we talked about earlier, but the distribution of salt, that is what happens to the salt after it is distributed to the road, that will not be included. That is because there is no LCA information yet on what happens to the salt, how it affects the closest environment or humans, or so that somebody else has to take on in their PhD. But it's clear from the earlier work that we've done that the fuel consumption is the main contributor of emissions. And that's why we think it was important to take into account other routes that include other elevation profiles and other weather situations. So we have now included the stretch from Orkanger. We are still working with the stretch from Orkanger down to Vinjøra, and then from Orkanger and up to Storås, and then road 700 from Svarkmo to Meldal, and 701, and then also E6 from Trondheim to Orkanger, and then E6 towards Oppdal. So we get a kind of a different variations of roads, so we can compare what effects the elevation and weather has on the fuel consumption. These roads also have different traffic amounts, so that's also interesting for us to know. So I have signed a confidentiality agreement, so I'm not going to share any of the information we have. But we have a huge set of data that's being modeled and analyzed with regard to fuel consumption and how the fuel consumption is influenced. So all the information we have is based on GPS points, and along with the GPS points we have fuel consumption, speed, what tools are being used and as it is on a GPS coordinates, we have time and date, so we can look at different routes, different days, different months, and then take an average, if we want, of the different periods. The data also allows us to link towards weather in that moment of time. As we would really like to see the effects of the two different tools used on the winter maintenance vehicles. The tools used suggest not only what the weather is like. So if you're using much salt and we see that the temperature is fluctuating around 0, that gives us an indication of what salting means for fuel consumption. We feel that there's a lack of overview over the environmental impact of winter maintenance. So we are trying to get a better overview over both LCA and other environmental estimates of winter maintenance, and generally on construction and normal maintenance, should we say. But as I said earlier, each road is unique. So when it comes to design, the amount of earthworks, the materials, the maintenance, the weather conditions, everything is different. So we need a good overview of everything that is available so we can kind of put it together in a reasonable way for Norway. In the end, the data that we have, the models and the general knowledge offers a great building block to something that is greater than the individual project. Gaylord is working on his huge model, and Babak is working on his things. So together we have a great set of building blocks towards something that is potentially very useful. So we would like to combine the work that we have all done into a system-like approach or a scheme that allows for early planning estimations that includes every aspect of the road planning, both construction, maintenance, from design stage. Having such an opportunity would allow for different aspects of the road infrastructure to have effect in the planning stage. And that would allow environmental issues to be included, which is maybe mostly done after the design has been decided today. The route selection based on LCA could allow winter maintenance, for example, to affect the selection between tunnels and overpass. That would say if you have a certain stretch of road that either can go over the mountain or through it, maybe the amount of winter maintenance throughout the lifetime of the route would be so much that it actually is better to make a tunnel with its construction and maintenance of the tunnel. So that would mean that both cost and environmental effects could be the main drivers for route selection. So that would be very beneficial for decision makers to have information early on, and that would mean that you would need a quick guide that would be easy to use, or maybe even tables over average both tunnels and overpasses to be able to estimate roughly what each route selection would contain. There are several challenges with the project, and mostly the challenges with the contractors. There are really many contractors, and the subcontractors only add to that number. So overview over what information is available and actually getting access to it is quite a challenge. But we have found a good solution, and now we have come to a great set of data. But we also think that there is a lot of reporting going on towards Statens vegvesen from the contractors, and we hope that in the future we would having more information on winter maintenance would maybe help Statens vegvesen to pressure the contractors to having more sustainable view on winter maintenance. But that's a future part. So finally, now you can see why winter maintenance is important to me personally. This is the road, the only road to my hometown in Iceland. It's 600 meters over the sea, and it actually snowed a lot that winter. But in the past, during the 90s, this was very common to see. This is a friend of mine from Australia. He is about 170 centimeters tall. So this is, and they just removed the snow the same day. So this is quite the amount of snow. So thank you for listening, and please have some discussion. Kersti, maybe.
Yes, we're open for question now. If anyone wants to do a question, you can write it or you can unmute so that you could ask the question.
I have one question.
Yeah.
Do you hear me?
Yeah.
Yeah. My name is Tom Norbeck, and I have taken on the role as project leader for sustainable infrastructure.
Yeah.
In E39, and you said that by building a tunnel, the life cycle emissions would go down compared to having winter maintenance.
No, that's not what I said. I said if you had a route that had both options,
yeah,
you could find out if the winter maintenance would be. So you could find out if it may be better to build tunnels.
Okay, but I don't think you. I would assume that you wouldn't mention it if it wasn't any chance that it would happen. You see it as a possible option, I guess. Then
I see it's a possible, yeah. But we have to. That's what we're gonna find out now in the next step in the project. Because now we're going through more of the elevation and weather-related data. Yeah. So if you have a certain mountain pass and you have the weather data from before, how the weather is on the mountain generally, then you can calculate fairly easily how that would affect the fuel emissions and then compare it. Because the road over the mountain also needs maintenance, right?
I see.
So both tunnels and the overpass need maintenance, but it's a question about what is included and how you would. Yeah.
But if you, in the future, if these vehicles were to run on hydrogen, then the tunnel wouldn't have any chance, I guess, in such a calculation.
Yeah, I don't really know. Because we haven't linked together the different fuel types to winter maintenance yet. But maybe with the help of Gaylord, it is possible to do so before we finish. That would be really interesting. Hydrogen or even electricity or... Yeah. But that would be That would be really interesting, because then we would reduce emissions by a lot.
Yeah.
That's clear.
Yeah, I agree. That would be really interesting. I hope you get the chance to do that.
Yeah, that should be when Gaylord has finished his part and I finished mine. That should be fairly easy to estimate.
Good. I'm glad to hear.
Yeah, Kjersti, you asked about the quick guide. I'm thinking that there could be a quick guide only if you want to have like overall kind of like a list. So you would have a graph that says, okay, the overpass is so high, the tunnels would be so long, and then you would have the different ranges, and you can see how it would, but that would be like really rough estimation, but that would be easy to use and really available to decision makers that might not know anything about LCA or the procedure. So you wouldn't need that much knowledge in forehand to use it. That's what I see.
Yeah, that would be a good thing to have.
Yeah.
I also have one more. If you read it.
Yeah. Road gradient. Earlier we've seen 450% increase in fuel consumption when we have 5% gradient. Snow has greater impact. This is actually, compared to what we saw, it's not nearly as high as 450, but we didn't have 5% gradient. That was almost non-existing in the road that we had. So when we analyzed the route to Oppdal, that might be more interesting. But even then, I'm not sure if we have that many stretches actually to analyze that have 5%. But when we were looking at it, it wasn't that high of an increase. But when we had the snow, or when we had the increase between September, for example, to January, the increase was way higher than going from 0.1 gradient to 3.4. Oh yeah, inside the tunnel. Yeah, okay. Yeah, 5% in the tunnel. Yeah, that's.
But at what rate did the fuel increase when you had less gradient on the road?
It was about 50 to 70% increase, okay, if I remember correctly. But I would have to look it up. But it was, about that.
Okay. It could be really interesting to hear about if you compare it to the gradient and if you see any difference.
Yeah, that's what we're working on. And we also wanted to include more roads to get more variation, because in the beginning we only had 2 vehicles that were driving this E39 stretch. So we'd like more. Now we have more vehicles and we have more road types. So that's gonna give us a more accurate picture of the effect of both the weather and the road gradient. Yeah. Anything else?
I see Gaylord is writing, but while he's writing, the impact on the E39 as a whole.
Yeah.
What do you think the impact that the work that you do would influence the E39 project?
Well, if all the tunnels are not built yet, it could influence that. But mostly it will give a picture of what the winter maintenance is emitting. It could be calculated for E39. What is it is emitting today, and how you could possibly reduce it. Because the other projects include electricity hub, for example. And if you have the electricity hub, then you might switch the vehicles to electric, right? So that also gives an impression of how you could reduce it, as there are goals in reducing emissions from the road infrastructure. So as Norway needs to show that they have reduced anything, so this could aid in that sense. Yeah, Gaylord is still writing.
Hello, this is Rolf van der Bone, Hrefna supervisor. I have a message for both Tom and you, Kjersti, if you are listening.
Yes.
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 So clearly, you know, and we are touching in many projects on this, and what Hrefna is doing is one part of the puzzle, and Gaylord, Barbak, and also Rain is other parts of the puzzle. But there are even more pieces that we haven't really started on yet. So clearly, to answer the questions you have, we need to continue this work and add some more pieces to the work in the future. But we are on the way, and so to help you with your problems, so to say, this is so what Hrefna now said was that we are going to put these together, hopefully during the next year, to answer some of your questions, but then we will also open a few more questions. But in the end, if we can balance all the different aspects of fuel type, gradient, over or through the mountain, then we can give some good advice on what to prioritize when you are constructing the future E39 and other roads, of course.
That's good to know, Rolf, because we will probably come back to you very shortly about those questions.
Yes, and I'm already in a discussion with Tom about it, but no, as Tom knows, we are finishing the Elingo report on should we or should we not electrify the heavy transport.
Yeah, that's a great question, actually.
So the answer to all your question is, of course, clearly more research is needed.
It is, yeah.
As always, it's a joke, but it's also a truth. We are slowly gathering a lot of good information that could help. But there is also a lot of unknowns that is on the table regarding electrification and other aspects of the future transport.
And just only that putting together our work, me, Babak, Gaylord and Rain, that is going to take some time. It's a huge work to put it all together.
But it's a great thing that you work on the same topic at the same time, so that you really have the opportunity to put it all together.
Yeah, that's really good.
Yeah, and I'm really looking forward to the results that you will produce in the end.
And that's also thanks to you and in Statens vegvesen that kind of the activities in Gothenburg and NTNU has been funded in such a way that we have gotten and used the opportunity to collaborate extensively.
Yeah.
Good. That's good to hear. Okay, do we have any other people that wants to ask questions? I see Babak is writing.
Yeah.
Okay. But then I think if no one else has a question, I would like to use the opportunity to remind you that we will have another presentation on the 8th of February. It will be Reingard Tan who will talk about, let's see the topic, Evaluation and improvement of crack with calculation methods of large-scale concrete structures. So that will be a little bit more on the construction side on the next time. Okay, I don't see anyone else coming up. So I think Hrefna, thank you very, very much for the presentation. It was a great one. I have put a small thing on LinkedIn, so if you would like to like and share, that is possible. I will also, as I mentioned, put it online on Monday, if I'm not able to do it today. And then you can all see it again there. Okay, so thank you everyone, and then I will stop the recording.